Alright guys, quick little review just in case you weren't here. You always have the video to watch if you weren't here. What's the square root of 121?
11.
I like that. You should really know up through 13 at least squares, right? 1 squared through 13 squared, maybe even more. Let me try to influence the next step here. What's the square root of -4 squared? Can't be, cannot be. What's order operations say you do first? Inside. You do the inside first. What's -4 squared? 16. And what's the square root of 16? 4. The square root of 16, that symbol means what? You don't have to tell me the name, but maybe if you know the name, you can say it. That symbol.
What symbol?
The square root symbol. What is it officially called? What does it officially reference? The positive root, right? The principal root. Because how many square roots does every positive number have? 2. A positive one and a negative one. I like it, right? So that symbol means, tell me the positive one. The answer always has to be positive. Is it cool?
What about the negative?
What about the negative? So this is the positive root of 16. If I want the negative root of 16, I write negative root of 16. And what's that? That's 4, so that's -4. Because if I said, what are the square roots of 16, what would you say? -4 and 4. I like it. So if you want the positive one, you use the square root symbol. If you want the negative one, you put a negative on it, saying, I specifically want the negative one. Thank you. Is that, you guys with me? Okay, I'll take that as a, sure, Jeff. We talked about this yesterday. So what is, if I don't say anything else in the problem, what is the square root of x squared? No? Absolute value of x. Because what did we just say has to be true? The answer to a square root has to be positive or 0, right? So absolute value is what forces it to be positive. I like it. Let me stop here. Yes?
So on the test, if you write the square root of x squared, does the answer have to be?
Yes. If I don't say anything else, you'll see in the homework they just say write the square root. You know, they don't say what's the square root of x squared. But if they say assume that no radicands were created using negative numbers, oh my God. That means the radicand is just the inside. The radicand is the official word for the inside. So if they say assume that the inside can't be negative, then you don't need to use absolute values. But in general, you have to. Yes, ma'am?
But you only use them for like a variable. Like, you don't use
Yeah, exactly. A number, you can determine it. You know. Just like, that's why this problem is really a good one. Because officially, you could just go, okay, this equals the absolute value of -4, which is 4. So you could use absolute values if you really needed to, but you really shouldn't, right? You just do it this way. But it still works this way. Square root of x squared is the absolute value of x. The absolute value of -4 is 4. That's why the square root came out to be 4. Okay. I like that. Everybody's somewhere between confused and bored. I love that spectrum. I'm on the spectrum of confused to bored. All right. So what is the cube root of x cubed? I love how some of you guys are 2. Now, if you put absolute value of x, it's not just unnecessary, it's wrong. Why is the square root, why are even roots so freaking uptight? Because I take any even number of real numbers. So if I had 4 2's, if I multiply them together, the answer is positive. If I have 4 negative 2's, if I multiply them together, the answer is positive, because the negatives cancel. That's why even roots are so uptight. This is how I look at them. Even roots, I can't have a negative answer. I can't handle negatives inside. I freak out. Odd roots, totally laid back. What's 2 cubed? 8. What's -2 cubed? Yeah, -2 times -2 is 4 times -2 is -8. See, cubes, odd powers, keep the sign. So their roots will be laid back. You're like, whatever you are, stay that way. I'm like, you guys are so easily, you're focused. Okay. So there's like a homework problem. Let me make it even worse. What is the 101th root, 101st root of b to the 101? B. You can actually do this. This is kind of nice. The 101st power is the opposite of the 101st root. They undo each other. And it's an odd root, so the answer can just be B. What is the 78th root of A to the 78th? Absolute value of A. I love it. Why? It's an even root. They freak out. We got to say it. We got to, oh, it's okay. Look at those absolute values. Look at a little security blanket. Here you go.
Wait, so for the one before that, why is it just?
Yeah, why is it just B, that one before that? It's an odd root. Odd roots are allowed to be negative answers because odd powers could come out negative. Even powers can't for real numbers. Maybe. That actually has a lot to do with why I can't do a sum of squares factoring, but I can do sum and difference of cubes. Odd powers always more laid back. Even powers very uptight. That's sort of the way I look at it. Yes.
But if you had an odd, if you had an odd exponent, wouldn't you want the absolute value just and if you had?
But it would be wrong. So let's do an actual concrete number inside. So if I had, what's the cube root of 27? 3. Why? Because 27 broken up into 3 parts is 3s, right? So see how this is very related to the first step of the cubes. A cube root wants to break it into 3 parts and take one of them. That's 3. So what is the cube root of, we're getting way up there in Roman numerals. I love it. What is the cube root of negative 27? Negative 3, because negative 3 times negative 3 times negative 3 is negative 27. You do not want to use absolute values because if it's negative, it's got to stay negative. If it's positive, it's got to stay positive. You can't force it to be positive or else that second one would have been wrong. So if there's variables inside, you got an odd root, you don't have to worry about absolute values at all. If they're negative, that's cool. They can stay negative. Even roots, oh shit, it might be negative. Put an absolute value right. Maybe. Okay. All right. Let's do some new stuff. Let me give you guys, I haven't given this to you yet. We're going to get this sucker right now. That'll probably help if I give this to you. Now, if you look at the back, I apologize for the interesting formatting. We'll try to work through it. What happens. There's a loss in translation between me and the print shop. Now, guys, please, I'm about to be, this is a really weird phrase, but I'm going to be very honest with you about this. We don't look at this entire problem yet. A square root, what are the square roots of 9 again? 3 and negative 3, I like it. So there really should be 3 cube roots of a number, 4 fourth roots of a number, so forth. Does that sort of make sense? We only look right now at the real one. The other 2 roots would be complex, would be imaginary. All right, that's all I want to say about that. So don't freak out. We're only going to look at the real roots. Later this semester, we'll discover how to get the imaginary roots, even if you don't want to. We will. So this is a very similar kind of definition to square roots. Can you take a cube root of a negative number? Yes. Yeah, we just did. So that's an easy one. Yes. How do you know? Because we did. We already did this one. Cube root of 27 is 3. I like it. Because 2 times 2 times 2 is 8. And then you got to make it negative so it ends up negative. Let me stop there for a second. Are you guys with me? What do you think about this one here? Zoom in on that. Well, you got the paper. Yeah. Yeah. No. Guys, why is that? Do it the same way I did cube root of 8 was 2, because it's 2 times 2 times 2. What do you multiply 3 times to get b to the 6? B squared, b squared, b squared. Doesn't that feel like the cube step? If I saw b to the 6, it was a cube, so I put b squared, b squared, b squared, because that's cutting it in 3 parts.
Well, couldn't you also divide the exponent?
Beautiful, I love it. We're working in that direction. So I want it to make sense right now based on what we know so far about roots, and then we're going to make a better way to look at it. So that's b squared. So the shortcut is 3 goes into 6 twice. We're going to see that when we realize that roots are fractional powers. And that's why it's 3 into 6. All right, we're not there yet. Now what about this guy?
Yes.
Yeah, cube root of 27 is 3. Cube root of x cubed is x. So I can have multiple things inside and just kind of attack them one at a time. Now, let me start to lay the foundation of this. What is the cube root of, let's see, 8 plus y cubed? Nope, I can't do that. The cube root of 8y cubed is 2y. No problem, because roots are powers. Powers play well with multiplication. Powers do not play well with addition, subtraction. The first one I cannot do.
So what's the answer? Can we say
It's already simplified. You cannot simplify it further.
can we say root 8 plus root 1?
Definitely not. That's the problem. So let's focus on this for a second. Because this is the thing that makes me sad about my Calculus 3 students who don't get this. And you're all like, if they don't get it, well, it's this level. That's why it makes me really sad. What about square root? Let's just talk about square root for a second. What's the square root of 9x squared? Assume all blah, 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 not negative, blah, blah, blah. Okay? Don't worry about it after that. What's the square root of 9x squared? 3x. Because it's multiplication. And roots are a type of power. They're on the same level in order of operations, for example. Powers do not play well with addition, subtraction. Right? Just to remind you guys, what the hell do I mean by play well? What the shit is that, Jeff? Well, I can do 2x cubed, right? What's 2x cubed? 8x cubed. That's amazing. But I cannot do 2 plus x cubed as easy. I can't just go, it's 8 plus x cubed. I can't do that. What would I have to do here? I'd have to write
2 plus x, 2 plus x, 2 plus x.
and then you get this big ass. You're with me at the point. Right? You guys with me? I looked like I was doing balloon things. Powers do not play well with addition because they're not based on addition. They play well with multiplication because they're based on multiplication. Roots are the same level as powers. They are actually a type of power. Therefore, if I had 9 plus x squared, square root, what is that? How do you simplify that? See? Can the square root go across a plus? What did we just talk about? So the answer to this is already simplified, or can't go further, or leave me alone, right?
Can we factor it?
Well, can you factor it?
3 plus x, 3 plus
Please say no. This is sum of squares. Even if you could, it's not going to go anywhere. Already simplified, or can't go further, or something. That's my point. Roots cannot play with addition, subtraction. Yes, sir? There you go. Okay, so let's look at this. If I had the square root of x squared plus 6x plus 9. Now, I can't attack this directly and say x plus square root of 6 plus 3. I can't do that shit. But what can I do with that? And how's it factor?
x plus 3 x plus 3.
Which is?
X plus 6 squared.
Which is?
X plus 3.
Yeah, for right now, because I said assume no, negative, blah, blah, blah. But in general, it'll be absolute value, right? But for right now, I said assume it's all not negative, blah, blah, blah. Yes?
Wait, so you can do that there? Because
Of course I can. Of course I can. Because what's the operation right there? Multiplication. I can rip that multiplication apart. That's what roots want to do. They want to break it up. If it's multiplication, it can't do shit to addition. That's not how, it doesn't have that power. Maybe. That's why I can do this one. It can rip that multiplication apart. Watch this, guys. Isn't 9x squared 3x times 3x? So it rips one of them out there. Right? But this guy can't do anything to it. This guy can't do anything to until I factor it and go, oh, cool, it's x plus 3 times x plus 3. I can rip one of them out, no problem. Because it's times, right? Maybe. Okay. We'll do some of this calculator stuff in the labs tomorrow and the next day. We'll see if you can find this cube root button on the calculator. There is one. It's not on the face of it. What do you think about this? Should be able to answer this based on what we've done. Domain is related to what? X. It's the inputs. So for a cube root, is there any numbers I'm not allowed to put in there? What's the cube root of 0? Why? I like that, Mark said. Because 0 times 0 times 0 is 0. So any root of 0 is 0. Any root of 1 is 1. I like it. So you can put 0 in there. Can you put negatives in there?
Yes.
We did. So, yes. Cube root of negative 8. We did that one earlier. It's negative 2. Can you put positives in there? Yes. So what's the domain? Is there any numbers I'm not allowed to put in there? All real numbers. The domain is everything. And what's the range? All real numbers, because I can get all the positives. 8 cube root is 2, 27 cube root is 3, so forth. I can get them all, and I can just get all the negatives going the other way. So the range is also all real numbers. I like it. Okay. Here, let me see. No, we'll do one here. So, obviously, hopefully, it doesn't just stop at square roots and cube roots. It goes forever. You can talk about it. I did a 101st root earlier, so, right? And the higher the root goes, the more parts it tries to break it into. So the higher the root goes, the smaller the result is. It's going to be a smaller and smaller piece because I'm cutting it up into more and more pieces. Okay, maybe. How the hell would I start to attack this? Don't just shout out the answer if you got it in your calculator already. I don't care about that shit.
You gotta break it up.
Got to break it up. Why is the cube root of 27 3? Because 27 is 3 times 3 times 3. Cube root tries to break it into 3 parts. Square root tries to break it up into 2 parts. So fourth root wants this sucker broken up into. So try to break 256 up into 4 parts. Or at least pretend to do something. How do you start to break that sucker down? Break it down. Say again? A tree. No way. Yes. You can do a tree.
I just squared it 2 times.
Huh?
I just squared it 2 times.
Squared it?
Yeah. Squared it 2 times. 4, so it just means whatever. So that.
What's the square root of 256? Just out of your head. Out of your head. Out of your head?
16. 16 and 16 is probably.
I like it.
And then square those things, you get 4.
Yes. But this one we're doing completely by hand.
Yeah, I
And
did.
not everybody knows square root of 256. All right, you guys ready? How are you guys? What's the first step you guys did here? 4 times 64? I like it. And then 64 is
8,
okay, cool. I'm gonna do that. 8 times
8.
8. And then 8 is 4 times 2, so 8 is 2 times 4. Now watch, what do I got? I got 4, 4, 4, and 4. So how, when I break it into 4 parts, what do I get? 4 times 4 times 4. Times 4. 4 parts. All right. Let me show you guys. If you're a little bit freaked out about being able to do that, let me do that. There it is. Let me put it over here. If you take 256, give me a minute. If you start with just 2, that's 2 times 128. And then 2 times 64, and then 2 times 32, and then 2 times 6. I mean, you can all do this, right? And then 2 times 8, and then 2 times 4, and then 2 times 2. Holy shit! How many 2s is that?
8.
3, 4, 5, 6, 7, 8. So there's 8 2s, which means there are 1, 2, 3, 4 4s. So if it was the 8th root of this bad boy, if it was the 8th root of 256, what would the answer be? 2. Because how many, if I break 256 up into 8 parts, I get 8 2s. So the answer would be 2. Let me make sure you guys really understand this. You guys know how to square root 16, but you don't know the right way to look at it necessarily. Square root of 16 is 4, because if I break 16 up into 2 parts, I get 4. So the answer is 4. What's the 4th root of 16? 2. 16 is 2 times 2 times 2 times 2. So the 4th root of 16 is 2.
Did you just add the 2s?
No. What do you mean? Sorry.
No, no, not 2 times 2. I mean, like.
Oh, yeah. There's 8 2s. If I break 256 up into 8 parts, they're all 2. So the 8th root of 256 is 2. Another way to look at this is, the question is, what does it take 8 of to multiply to be 256? It takes 8 2s to multiply to be 256. I love it. A lot of you guys, let me mention something. There are things we haven't talked about yet that will make some of this easier to think about. There are other ways to say these things. That's fantastic. I love it. I try to give a few different ways to do things, because not everybody sees the same thing as easy as somebody else. I can just tell on some of your faces, you're like, why is he talking about that shit? It's so much easier this way. Screw that. It's easier for you, but not for everybody. Right? So there are several ways to look at this. To me, one of the best ways is what I just said. You can always read a root as the index. This little number here is the question. What does it take this many of to multiply to be the inside? That's why breaking it down makes sense. So if it's now, we actually have the 4th root of 256. So that's why I have to make groups of 4 groups, right? So that's why the answer here would be 4. What's that? What do I have 4 groups of? 4, 4, 4, 4. 2 times 2 is 4. There's 1. So I have 4 groups of 4. So if I break 256 down into 4 parts, it's 4. 4 times 4 times 4 times 4. The same way that 27 broken into 3 parts is 3 times 3 times 3. Same way. Bam. So here, you guys do this. What's the 4th root of 81? Don't say it out loud if you know it. I love you guys. Why is that? Because 81 is 9 times 9. And 9 is... So what does it take 4 of to multiply to be 81? 3. I like it. I like it. So that's a nice way to read that symbol, is to know what the question is. What does it take 4 of to make the inside multiply? It takes 4 3's multiply to make the inside. Okay. Here. Try this guy. It's the same way. Don't say it out loud. Bless you. And let me say one thing, just in case anybody's like, I'm not going to worry about this shit. I know where my root button is on my calculator, Jeff. Why would I worry about this shit? Because I'm going to have a part of the test that doesn't have allowable use of calculator. That's why, right? Oh, you mean I got to know something in my head instead of in my hand? Yes. Holy shit. So some of you guys might know some of these numbers already. But if you just start to break this down, yeah, sure, you do 8 times 4. The negative I'm not going to worry about too much. That negative just means the answer is going to be negative. And then I can just focus on the number, right? I don't have to worry about the negatives. 8 is 2 times 2 times 2. 4 is... So what does it take 5 of to make 32 when you multiply? 2. And it's negative, so it ends up being negative. I like it. So you can kind of take care of the sign and then just worry about the number. You don't have to carry negatives around with you everywhere. We already did number 3. We just did it. Except we got 4th root of 81 was 3. So the negative 4th root of 81 is? That's pretty easy. All right, you guys do this one. Don't say it out loud when you get there. See how long that holds. Again, I don't care if your calculator can do it. Well, you do it. Well, the funny thing about this one, let's see if you guys remember the rules. It's not even, so it can't be divided by 2 or 4 or 6 or any of those even things. When you add the digits up, you get 7, so it can't be divided by 3 or 6 or 9. Do you remember those rules? What do we got left? So it's not 2, it's not 3, it's not 4, it's not 5, right? That's the easy one. It's not 6, it's not 8, it's not 9. Holy shit. Yes, sir.
My dad was telling me about back in the day when he was in school, like in the 60s, they didn't have calculators. They had to use their brain.
Holy shit. Sorry. Still. I gotta stop. Damn, I gotta stop cussing. Now guys, if Evil Jeff gives you this problem, you know it's going to be 7. You know the answer is going to be 7, right? How do you kind of check that real quick? If the answer is 7, that means that 7 times 7 times 7 times 7 is this. So you do 49 times 49 just to verify. And sure enough, 49 times 49 is that. So the answer is 7. So what is the square root of 2401? 49. Kick ass. Because it takes 2 49s to make it. Fourth root of 2401 would be 7 because it takes 4 7s to make it. The cube root, I don't know, shit. Yes?
Okay, so if you like did on the test, like let's say you have that problem, because if you know that the square root of 4 times is like 3, so you're not asking bigger than 3 but less than 10, you just use that. Is that like
Whatever that helps you narrow it into being 7. And if I gave you this problem, you can pretty much do what I just said here to verify. That would be your work. You can figure out what the number is and then just verify that it's true. Yeah. Okay. Say again?
It literally adds up to the answer.
Say again?
It adds up to the answer.
Yeah, these multiply to be 2401,
I'm
right?
talking about the number. Adds up.
It adds up? Oh, yeah. Yes. Don't generalize that. That is a coincidence.
I know,
Those are the most evil things. Alright. Here, this is sort of a... Hold on, you guys try number 1 there. It's just reminding you about function notation. Alright guys, so what is... Be careful. I am allowed to put -4 in this. What cannot happen though is the inside can't end up being negative. So because I'm subtracting the x piece, this is going to end up being positive. This is the square root of 4 minus 12. John, try again, Jeff. 4 minus -12, so 4 plus 12 is the square root of 16 is 4. What about f of 0? Square root of 4 minus 3 times 0, square root of 4, 2. And then f of 3, square root of 4 minus 3 times 3, square root of 4 minus 9 is square root of -5. What would you say? Not real. My gosh.
Would we get it wrong if we just left this word in -5?
Yes. I need you to realize, I need you to get really used to this idea. It doesn't mean, right now this isn't a good answer because it doesn't mean anything to us yet. We don't even have these numbers yet. So we're like a civilization that we would just go, blasphemous, that's crap, you know, or whatever you want to put it. You might not say it like that. I like that, blasphemous crap. What about this guy? Try this one out real quick. Oh wow, like real quick. So this one we'll talk about in the labs tomorrow, and the next day we'll talk about how to do some of these in the calculator. These first you could do. What's the cube root of negative 27? Negative 3, cube root of 8, 2. I like it. This one would be a calculator problem. It exists, but it's a gross number. Yes?
Why can you do the negative 27 times the negative 5?
It's because if I multiply negative 3 by itself 3 times, so negative 3 times negative 3 is 9. Oh shit, times negative 3 is negative 27. The negative comes back. That's why even ones, they lose the negative, they don't come back. Odd ones, the negative comes back, it's allowed to be negative. Real quick word about the back, just in case you start to look at it. Sorry about this. Obviously, it would look fine on my computer, but not so good on the print shop, so we'll try to untangle this tomorrow. Okay. I'll see you guys, some of you guys soon. If you didn't get your test back yet, come up here.
So answer. 8 plus
There is
y.
no answer.
No answer?
You can't simplify that.
Okay.
Not simplifying it.
What
Unless I
about-
knew a value of y, maybe for some values of y, but not for every value of y.
We cannot say root 8 plus root 3.
Completely not. Because watch. Here's what I meant to do. Square root of 4 plus 9.
We cannot factor 2 plus
Look.
y equals.
No. That would be a little too big to.
Yeah.
It wouldn't be 3 of anything.
Yeah.
Square root of 4 plus 9 is not 2 plus 3 because 4 plus 9 is 13. So it can't be 2 plus 3 because square root of 13 is not 5. Square roots can't, just the same way that squares can't distribute across a positive, right? Roots can't distribute across a positive either. Or, plus, or minus. Okay.
Can I have one of those worksheets for a classmate that missed us?
Do it again.